Hello everyone, welcome to this presentation about data processing the simple way with Apache Spark. During this meeting, I will talk to you about Apache Spark and how you can run it through many ways in order to process your data. Especially, I will talk to you about the job as a service model, which we choose to implement one of our solutions at OVHcloud. But first, let me introduce myself. My name is Gallot. I've been working at OVHcloud for 2 years now as a DevOps in the data convergence team, which is a big data solution-oriented team. OVHcloud, if you don't know, is a global and the leading European cloud provider. We have 30 data centers all around the world, mainly in Europe, but also in North America with our 7 data centers located in the city of Beauharnois in Quebec. We are hosting about 350,000 public cloud instances, and we are in partnership with Intel. So now that you know a bit more about me and OVHcloud, let's see what we are going to talk about during this meeting. So first, I will make a short introduction about the big data and how to process it, mainly with Apache Spark. Then I will talk to you about the different ways you can run Spark, namely the on-premise way and in the cloud, with the job as a service model and the cluster as a service model. After that, I will talk to you about OVHcloud Data Processing, which is our implementation of the job as a service model. And finally, I will show you how our partner is using it. So let's start. As you may already know, we are producing more and more data every day. Those data come from many sources, such as the IoT devices, our social media, or the internet navigation. And what you need to know is that those data can represent a huge value for different fields of activity, like the industry, the marketing, different kind of business, and for science as well. So we may be interested in process this data in order to extract value from it. What we usually do when we want to process data is that we take our spreadsheet software, like Excel or our relational databases. But in the case of the big data, you may have billions of lines of data, or even worse, you can have no line at all, but videos or audio tracks or images. And in those cases, the traditional tools are not enough to process it. That's why we need more appropriate tools. And I mean by that, distributed computing tools. Why distributed? It's because it means that you can run tasks and process data in parallel across several amount of machines, and thus save a large amount of time. Among those technologies, Spark is one of the most popular, and it's not for no reason, as you will see just after. So, what is Apache Spark? Spark is an open source distributed computing framework. It has one of the biggest open source community in big data, which makes it really easy to find support about it. It's also really fast, and it's compliant with languages that are already used by data scientists, such as Java, Scala, Python, and R. Let's see how Spark works. As it's a distributed computing framework, it means that it has to work on a cluster. A cluster is composed of several nodes, like a master node and one or more worker nodes, which are on the same network. Spark also needs a cluster manager to manage the resources of the cluster, and the main program, which is the Spark driver on the master node. This program allows to create Spark context object when you create a job, and the Spark context is the object that contains all the information about your job, such as the number of executors you want and the resources allocated to each of them. Those information are used by the cluster manager in order to actually spawn the executors, and once it's done, the job can run and distribute the data and the task between the executors to run it in parallel. To sum up, what do you need to process data with Spark? First, of course, you will need data. You will also need a code or a script in order to describe what your job is supposed to do with your data. But most of all, you will need a Spark cluster, and that's on this point we are going to talk a bit more today. To get a Spark cluster, you have two options. The first one is to get it on-premise, and the second one is to do it in the cloud. Let's say you want to do it on-premise. First, you will need servers, of course, and if you don't already have them, you will have to buy them. Once you have your servers, you will need to configure them, to configure the network, to install and configure Spark, and your cluster manager. If you are already owning a Hadoop cluster, then great, you can use Yarn as Spark as a cluster manager. But if you don't, then you will have to configure it with a standalone version or Kubernetes or Mesos. Once you have your cluster ready to use, you will still have to manage it. If you have hardware or software issues, you will have to handle it by yourself and to upgrade your Spark version by yourself as well. It will be quite difficult for you to scale your cluster if you want to have a smaller one or bigger one, because you will have to get rid of your servers or to get new one and configure them. All those things require a lot of time, money, and experienced people to do that. So it can be quite difficult to handle. Your other option is to do it in the cloud. In that case, you don't have to worry about the infrastructure because your cloud provider is doing it for you. You only have to order your infrastructure, and after that, if you regret the size of your infrastructure, you can scale it really easily. You can just click on the button to get more servers or less. Moreover, it could be really interesting to think about doing it in the cloud because the data tends to be more and more stored in the cloud, which means that if you want to get as close of your data as possible, then your cluster might be in the cloud as well. And it will enable you to avoid network latencies or issues. So if you want to do it in the cloud, there are several ways to do it. I will talk to you about two different models today. The first one is a cluster as a service. With this model, of course, you are getting your infrastructure from your cloud provider, but it's ready to use. It means that the cluster is already configured, Spark is already installed, and everything is just ready for you. It means that you don't have to do it by yourself or to pay anyone to do it for you. And as it's in the cloud, you can choose your location and you can scale it pretty easily. It will only take you to click on the button and wait a bit to do so. But as you are owning your cluster, you still have to manage it afterwards. You maybe have to handle your Spark version by yourself or any other software issues that may occur. But first, you will have to think about the size of your cluster. And to do so, you will have to ask yourself some questions like, how many simultaneous jobs will you run? What will your job size be? And how fast do you need your job to run? Because the size of your cluster, the fastness of your cluster depends on the number of resources you are allocated to it. As you can see on this chart, which represents the data volume processed by one Spark job that is run either on a single node or on a Spark cluster with several nodes, you can see that the more data you want you to process, the more interesting it to have several nodes if you want it to be fast. So just think about it. Knowing that, you may be tempted to have a really big cluster in order to have fast job if you want, for example, to make real-time processing. But don't forget that when you have size your cluster and it's really big, of course you are paying for the resources you are using for your job, but you're also paying for the rest of your cluster and the unused resources of your cluster. So be careful not to size it too big. The contrary is also true, because if you make your cluster too small, you won't be able to spawn a job that wasn't planned at the beginning. You won't be able to add a new daily job to your cluster because it's already almost used by your other jobs. Of course, you will be able to scale it, but you still have to do it and to think about it. Another downside of owning your own cluster is that as it's a single cluster, it has only one Spark version. And the day you want to try a new Spark version or use a new feature of a new Spark version, you will have to spawn a new cluster in order to use it, or to upgrade your Spark version of your existing cluster, which means that if you have daily jobs running on it, you will have maybe to upgrade them as well. Another drawbacks you can think about is the location, because let's just imagine that you have your business in Europe, your data in Europe, and you spawn your cluster at the same location. Everything is fine until the day you have new customers in Canada and you have new data in Canada. So if you want to be as close as your data as possible, you will have to have a new cluster in Canada as well, and also paying for it. Unfortunately, there is another model if you want to do Spark in the cloud. It's the job as a service model. With the job as a service model, you don't have to think, you don't have to spawn clusters anymore, but you just spawn jobs. It means that you don't care about the unused resources because there are no unused resources. So you just focus on the size of your job. You can have different Spark versions simultaneously, and you can spawn different jobs in different parts of the world without any problem. So it's a way more flexible way to think of the data processing with Spark, because you just have to focus on your job, one job at a time. And of course, you're only paying for what you're actually using. So that's why at OVHcloud we found this model way more interesting than the others, and we decided to implement our version of this model with OVHcloud Data Processing. So let's see how it works. When you want to use OVHcloud Data Processing, you will first have to upload your job, your script, into our OVHcloud object storage. Then you configure your job and you launch it. And then OVHcloud Data Processing will retrieve your job and your data from the object storage or from another data storage, which is compliant with our security rules. Then it will take about a minute to start, and it will process your job. Once it's done, it will upload your logs in the object storage and your results wherever you want. You can use it through our graphical user interface, which is our control panel, or with our API, the OVHcloud API, but also with a CLI that we developed for this solution. It's open sourced, and it's really similar to the original Spark Summit CLI, which means that if you want to switch to a job as a service model for your applications, it will be really easy to do it because you won't have a lot of things to change in your script that are already using Spark Summit. Now I will show you a demonstration of our solution. So first you will need to have a OVHcloud public cloud account, and in this account you will need to go in the object storage section to create a container. In this container you will have to store your script, as I said. In this case, an environment.yaml for the Python requirement, and your data. Then in the data processing section, you can start a new job. First, you select your Spark version and your location. And then you can size your job with templates, or you can also use advanced configuration if the template does not suit your needs. After that, you just have to name your job, select the container you created in object storage, and your job type. You then enter the name of the script and you can submit your job. You can then see in the dashboard that your job is in submitted state. And now you can access to the job dashboard by clicking on its name. Here you can see information about your job, such as its status and the configuration you just set for it. You can also access the logs page, where you will be able to find the live logs of your job. So you will see the logs appear as the job is starting. You can also access the Spark UI, where you can get further information about how your job is doing. And you can see in the dashboard that we also provide metrics such as the memory usage, the task, and the disk usage of your job. Once your job is finished, you still can access the dashboard to see how it went, how much time it took, and you can also download the logs from your object storage. As I said, we provide metrics. You can visualize them with a Grafana dashboard in order to see if you correctly sized your job and maybe to correct that in the future. So now I will talk to you about our partner, Novagen, which is using our solution OVHcloud Data Processing. Novagen is a company that provides solutions for their customers when it comes to the big data concerns. So their aim in that case is to prevent companies to have lack of quality in their data storage. Here you can see a regular data pipeline with many data sources, a data storage, and then they can transform and get value from the data. But in many cases, there are wrong or missing or duplicated data from the data sources, and it makes a lack of quality in the data storage. And because of this lack of quality, we can make bad decision or BSML model, which is definitely not what we want, and it can cost a lot of time and money to fix that afterwards. So what Novagen wants to do is to diagnose the lack of quality as soon as possible in order to fix it before it's too late. And to do so, they developed the Novagen quality engine, which is using OVHcloud Data Processing. So to use it, first you will have to define your data source in their UI, and then run the first Spark job on it using OVHcloud Data Processing. This Spark job wants to retrieve the metadata of the source, and it's a quite short job. So the job as a service model in this case is pretty interesting, because if they had a cluster to manage, then they would have to size it perfectly depending on the number of customers that want to use the service. Because if they have to scale it, they will have to wait like 10 minutes in order to have the resources to run the job, where the job is only running for seconds. So it would be really painful. So that's why the job as a service model in this case is really interesting. So once the metadata are retrieved, you can select quality rules over the data sources, and then run another Spark job to apply the rules. So depending on the data source size of the amount of data provided by the data source, this job may require more or less resources, and it's again really interesting to do it with a job as a service model, as you can select your job size really without having to think about your available resources. So if you have only bigger data sources, then it's okay. Once the job is done, you can get the quality report, and if you want, it's optional, you can run a last Spark job in order to get samples. So as it's a not required job, it's a good thing that it's a job as model, so you don't have to count it when you size your cluster, because you don't have cluster. So Novagen saw that the OVHcloud data processing with the job as a service model was really interesting in their use case, because of that points, and also because it was really more cost efficient than other models and really flexible. And also really easy to use thanks to the CLI. If you are interested in OVHcloud data processing, then I let you know that it's for now only available with the Apache Spark 2.4.3 version, but soon we will be able to provide more Spark version and maybe more engine. You can say what you want to us, and we will consider that in order to add new features to our solution. We support Java, Scala, and Python as languages for your script, and the jobs can, for now, only be launched in Europe. Still, you can use it from all around the world, but physically, your job will be located in Europe. Soon, we'll be able to do it in North America as well. So that's it for this presentation about Spark and OVHcloud data processing. Thank you very much for attending to this presentation. And if you have any question, I will be glad to answer them. So thank you.